Hello and welcome to week 7 in Statistics for Psychology. And here is our first test of relationships. Now, in the field of psychology, we often are looking at variables, which we then operationally define. So I might look at intelligence, and I operationally define that as the scores on a test that measures intelligence and its relationship to another variable. Let's say donut consumption. And I want to know if IQ is related to donut consumption. Let's just say that I have a running theory that individuals that have high sugar diets actually provide their brains with a lot of extra energy in the form of sucrose, and therefore their brains are much healthier and they're able to perform much better. Okay? So people who eat a lot of donuts are smarter. So I'm going to look at a relationship between those. Now, before I can ever get into some sort of experiment where I'm proving that there's a relationship or providing evidence, more likely we would say, about that, I need to find out, do those things actually have a numerical relationship? And therein lies the use of the correlation. Now, I would then create a study where I measured a whole bunch of people's IQ, and I asked them how many donuts a week do they eat. And I chart that across a graph. And I will get what is called a scatter plot. You can read about this in the course book. The scatter plot is a dot on a graph where you have one dimension, intelligence, on one axis and number of donuts a week going along the other axis. And for each individual, I have a IQ score and a donut score. And that places a spot on the graph corresponding to how much IQ and how much donuts. That was each individual's. And each spot is each individual that I asked those. I have two numbers associated with those individuals. And those spots fill up that area of the graph. Now, if there is some sort of relationship between those spots, will seem to arrange themselves in, for the sake of what we're talking about now, a linear fashion. There is such thing as curvy linear relationships. That's for a later time. But if I'm right, I should see spots that correspond to individuals who are low in IQ, should have low donut consumption. And as you go higher, you'll get higher donut consumption, and you'll have the spots will kind of move along a line like that. Now, if I'm completely opposite, I would see high IQ associated with low donut consumption. And so the spots would go along a line going from the top to the bottom, from left to right. Now, there might be no relationship at all, and the spots would just be all over the place. Now, Excel enables us to be able to specifically define whether there's a line that can best represent that particular relationship. And this goes right back to geometry. The slope, the steepness of that line is the calculation of what we call the correlation. First, is there a line that represents this data? Yes, no. If yes, what is the slope of that line? And the sign of it, positive, means that both those factors move together, intelligence and donut consumption. That's a positive correlation. You would see that from, depending on how you arrange the data, but mostly the line would start on the lower left quadrant and move somewhat to the upper right quadrant on the graph. And if it was a negative correlation, meaning they move opposite to each other, as one goes up, the other one goes down. In that, we would see a line representing all of those spots going from the top left quadrant down to the bottom right quadrant. That general shape. Now, the value of the correlations ranges from -1, totally opposite, to +1, completely aligned. Now, those extremes are rarely found in the real world, so we have different levels of strength of those relationships. These do not entail any sort of causal relationship. That, if I graphed IQ and donut consumption and I got a line clearly indicating a positive correlation, that does not mean that IQ causes donut consumption, nor does it mean that donut consumption causes IQ. They may just relate to each other with what we call a spurious correlation, which just things that are out there that seem to be correlated to each other for no reason other than the universe has a sense of humor. That's it. There's no specific relationship with that. So the discussion has you do a search on the web to explore spurious correlations. Now, I stole this idea of the IQ and donut consumption because I was just exploring myself, getting ready for today, some spurious correlations. And one of the spurious correlations that exists out there is high school graduation rates and donut consumption. Those are actually positively correlated. They do. We can maybe think about, well, people working hard, they're late at night, maybe they're eating more donuts, maybe there is a cause-effect relationship, but that's pure speculation. There is a strong correlation, but no causal effect can be implied by that. Now, so that's a real existing one. So that's the discussion, is for you to go out and find some of these. They're kind of funny sometimes, things that actually correlate in our world. Again, the universe having a sense of humor. I have a quiz where I'm asking you to wrap your head around those numbers of correlations that range from -1 to +1. So a correlation is always, it's a decimal, but it's always a fraction. It's always a rise over run. If you kind of think of that, showing the slope of that particular line. So it's point something. So it's -0.1, -0.3, all the way to -0.9999 until it's a perfect negative correlation. And then +0.1, +0.2. If you ever get a calculation for correlations that's like 45, something went wrong with the calculation. It is always a decimal between -1 and +1. That's where you're going to get it. If it's 0.8, 0.9, those are very strong correlations, negative or positive. So that's getting to know those things. And that is what the quiz is about, asking some multiple choice questions about that. In the assignment, you are going to be using the tools within Excel to analyze the correlation in a set of numbers. So I have given you a set of numbers that have performance indicators on a test and heart rate. So heart rate as a reflection of stress, and performance on the test as an objective method of focus and understanding and whatnot. So first, you're going to put that information to a table, and then you're going to use the tools to get the descriptive statistics out of that. Use the plugin to get the descriptive statistics for each one of those columns, which is the average, blah, 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 blah. And then you are going to create a scatter plot. That scatter plot is going to be a graph, just like I talked about, that on one axis is going to be heart rate, on the other axis is going to be performance, and for each pair, there's going to be a dot on that graph. You use that scatter plot to create the Pearson R correlation. When you are creating that within Excel, Excel gives you the option for the Pearson R correlation to be printed right in the graph. So you can also do a separate correlation. You can actually select a cell, put equals, start writing correlation, and it will give you those same sort of fill in the blank. And then you select all of the cells with both columns, including the titles. And you have it do a correlation on that, and it'll give you a correlation figure, a number between +1 and -1. So you get that correlation, and then you're going to go into the text box. Now, the text box asks you to describe the meaning of the number that you have identified. Is it a positive correlation or is it a negative correlation? What does it mean about stress and the relationship to performance on a test? Then the second one kind of goes a little bit into regression. Now, regression is a tool. It's already built into the correlation, and what it is when you are looking at, like, I think I give these instructions in the course book. You're looking at that graph, that scatter plot. You can select one of those spots. I believe this is how you do it. Select one of those spots, and it will give you the opportunity to create a best fit line. That best fit line is a straight line that is the best representation of all that data that's in there. You can also have it reveal the formula for that line. That formula will contain the X variable and the Y variable, depending on where. This is the X axis and this is the Y axis, depending on how you put that data in the data table. You got to be very conscious of what you're doing because it's not going to figure this out for you. So you have your data on a little table with all the numbers. You created a scatter plot. You have the correlation printed right in there, or you've done that in a separate cell. Select one of those spots. Insert the formula for that particular line. That is called the regression line. The best fit line is called the regression line. It's the same thing. That formula allows you to statistically predict one variable when you know the other. That's the whole. You have a correlation, and then you have prediction. Regression. It regresses the line mathematically, so that if I know one variable, I can predict the other one. Now, the variable that I'm having you do in question number 2 is I give you the test performance, and I want you to predict the heart rate. Remember which variable is which in the formula. And it also has to sort of make sense. So make sure when you're looking at that formula that you've had Excel produce out of that best fit line, that's the formula you're going to use. You're going to insert X or Y to solve for the other one. So you're mathematically going to have to do that. So make sure you keep track of what is X and what is Y, because you could switch those. You could have performance here and heart rate here, and it would switch the X's and Y's. So make sure you're solving for the right variable. That's a skill set. Just being very mindful about how you put data in, how you come up with a scatter plot, how you get the correlation, how you get the best fit line, how you get the formula from the best fit line, and how you plug in one of those variables, essentially a score of 92, would predict what level of stress, what heart rate, actually, specifically. And that's our assignment. So pretty funky stuff here. If you be careful and make sure you follow the instructions that are in the course book, just take your time, step by step. If something looks screwy, it might be screwy. Kind of think about the numbers. Do they make sense? If you did this and you put in the 92 and you did the formula and you ended up with a heart rate of 427, something went wrong. You would be dead at a heart rate of 427. You wouldn't get to do a 92. So something went wrong with the formula. Use that feedback from your Excel to research whether you have those variables in the right place or not. Some of this is exploratory, how it works on your own computer. Been pleased so far with everybody's efforts, particularly your efforts to persist. When you persist in using Excel to solve these problems, when you struggle with it and you're up late and you're mad, maybe you don't like me anymore, you're doing that kind of thing, that is amazing learning that happens. You are going to really solidify. That's way better than me just telling you what to do. It really is. So I kind of tell you what to do in the example in the course book. Use that as a guide to doing the assignment. So we had three things. We had the discussion on spurious correlations. We had the multiple choice quiz about what those correlation numbers mean, and the assignment where I gave you some data and you're actually going to get it into some analysis of the relationship between those two figures, the correlation number that's there, whether positive or negative correlation, then the strength of that correlation, the actual number, the computation and visualization of the regression line, and using the regression formula in a predictive manner in order to predict one variable knowing the other. Huge, huge part of statistics. All of our weather calculations, a lot of, predictions for resources that are needed, prediction on prices, and all that stuff are all related to those regression lines. One of the most important statistics that we have in our modern world. And you're going to be doing one right on your own computer. Very cool. All right, so that's this week. It's a big week. Correlations are big. The whole idea of regressions are huge. In fact, how they impact our lives. Have a little bit of fun with the spurious correlation. Those are always kind of interesting. See if you can find any that are really modern. I just initiated some searches and I found a few that are, of course there are some from a while back, but sometimes you can see in the news because people will say this and this are related, and you're like, hey, wait a minute, they're not. They're implying that there's a causal relationship here when this may just be a spurious relationship. Even when the causal relationship might make sense. Okay. Anyway, after we do this, we're going to slowly be transitioning into the test where we are examining causal factors. But first, before we explore any causal factors, we have to determine whether the variables are related. So all the tests that we're going to be doing from this point on are going to include doing a correlation to determine from the start whether or not there's a relationship at all. If there's no correlation between them, there's no reason to think that there might be a causal relationship between them. Good facts. It sort of saves you time sometimes when I think these things are related to each other. Oh, there's no correlation. They're not related to each other. Not going to happen. All right, so that's this week. Good luck with all of this. Post any questions in the questions discussion board in Brightspace. That's a good place to get help from each other, and I also monitor that board as well. So I look forward to the discussion on spurious correlations and for your further adventures in Excel. Have a great week.